Well, we've had the testing of the individual components, and what I've done a little bit today is integration of the two systems. So I'll walk you through it at a very high level. Last week we had a puff test where we had the puff board run by the transformer. It's designed to take AC in. There is a trigger input, and then there's a motor output. And the motor has nothing. It has an idle, and then it has a pulse, nothing, then it has an idle, and then it may have a pulse, and then back to idle, something like that. This is the motor. So this is like slow, and this is fast, and then this is zero, travel. So the motor goes through these tests depending on what this trigger is sending us. And the trigger is off of a cam next to the motor flywheel, or a wheel with bumps on it that triggers something. Okay. That's the puff board, and that's right here. You saw it last week. It looks like a menagerie. It's not that bad, just a few jumps around. The second thing you saw yesterday was the Chuff board. When I say that's the Chuff soundboard, so we have a soundboard here and a amplifier here, very small boards. This is a power supply, so it takes in power and it converts it to 5 volts, okay, DC, and it runs these two. And the amplifier simply goes to the speaker, and the sound sits here, and it's got circuitry, and depending on what happens to its trigger here, every time that trigger is pulsed, it will fire the soundboard. And if it's triggered again, so it'll be nothing, pulse the sound, and the sound will play, and then it goes to nothing. If you trigger it again, it pulses the sound. But if you trigger it again really fast, it'll pulse it, pulse it, pulse it, pulse it. So you'll hear a chuff, 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 depending on the speed. Okay? So they operate differently, but for the same reasons. The synchronization of the chuff and the puff, for the brain to hear and see smoke and hear the chuff sound, it ties those two together. Once it sees them, they're tied together. Now, for this thing to function, I just tested the Chuff board, the puff board, and I had this fan on to its circuit so I could watch it. It's hard to watch a fan that's all assembled there, right? So I watched the fan work, and the fan pulsed. It did pulse. And it pulsed every time this was triggered by this cam. Then I unhooked that, and I hooked in my sound system, which really only has these two leads here that get the pulse. And when the pulse is made, it has its own power, and it has its own circuitry, and it has a speaker, and it makes the chuff sound. And it did that. Now, the challenge is they have different different power requirements, and are not on a common ground. So what that does is it makes the trigger itself kind of complicated, because the trigger that I have now is a micro switch with a bump, and then I have a cam with bumps on it, and it has 3 leads, normally closed, normally open, and then a common. So here's the common, here's the open, there's the closed. So if we're going along and nothing's happening, one of these is going to be on the high side. So let's say this is low and this is high, okay? And when nothing's going on, you have it normally closed, right? So the NC is going to be sitting up here. The NO will be sitting here. And the common is going to be always on. So he's like always on. How do I put that? Put it here. Always on. He's always on. So what happens when it switches, say it goes through a time phase, right? He comes across the next time phase. if this cam comes over and touches this one, which is normally closed, now becomes open, so he drops. And this one that's normally closed, normally open, he's now closed, so he becomes high, okay? So there's continuity between this switch and this switch depending on the position of the cam. It's hard to explain, but at any rate, that's how it works. What I have done, I've simply taken the normally closed, the normally open, and say, or excuse me, I may have these turned around. I think it's normally open, normally closed. Okay, fine. Normally open, normally closed. So when this trigger gets closed, that says puff. Or if it's closed and it's hooked up to the chuff, it says chuff. But since they're on different ground systems, if this is the common, I'm sorry, I wasn't watching, was I? They're on different ground systems, I started to say. So if this is their common or their ground, and that's the pulse, this is the pulse, and that's its common and ground. How do I do that? I can't do that. That's what it amounts to. I can't do it. So I have to have a pair of somethings. Now, the pair of somethings, now I can wire them whichever way I want. It'll be fine because I have a separate signal and it comes in. Now this, if it's a switch like that, then you have to have two switches and two cams, or a cam and one switch, or two switches and one, it gets a little weird there. Now, if you have the infrared, you just have the two lights and a stripe. Now you can put the stripe on a wheel. The wheel has a front and back, right? So if you put one on the front and one on the back, you can have infrared chuff and infrared puff. You could do that. And so he feeds him and he feeds him, the same wheel, different sensor. Some of the challenges, those sensors require some power input. And so now you got a power and a common, and that has to be figured out. Many times these sensors don't matter. They don't care. If that's a ground, that's my plus, that's my plus. I'll be fine. When this is connected, I light. When that's connected, I light. And we don't really crosstalk. That could work. Pardon me. My throat's dry. I had a big lunch birthday celebration today. Okay. Now, the other idea that has been brought about was the idea of a small magnet. Here and here. So this is rotating. And then something like this. These are Hall effect switches, okay? And they would see the magnet. They take a voltage in. They have a common, and then they have a trigger pulse. So they get voltage in, common, and then trigger pulse out. So that could go to 1. Same thing over here, voltage, common, trigger. That could go to 2, whatever. Puff, chuff. That could work. And they're tiny. Pardon me. They are really, they're like that, tiny. So you could almost put a pair of them maybe, but you probably want them on either side or at a 180, so that when this magnet's here and that magnet's here, they pulse. They pulse in sync, but it's only because of the orientation. Now, I had not ordered these. Thought I had. I didn't. I have them anywhere. They come in around 50 cents each, so it's not a big deal. I don't know much about the specs, so I'm reading into it. I'm looking at microsecond response times, like 300 microseconds and 3 microseconds to unload. I don't know. This thing goes pretty fast. I haven't done the math to figure out at what RPM, at what things, how many microseconds per, I don't know. Don't know that. I suppose I should try it. That's always a good exercise for me to refresh on algebra. Not something I enjoy all that much, but it's good when you're done. I'll put it that way. I do have infrared sensors here that I can just create my own, if that works. I don't know. The challenge is I have to fit it in this space. That's all the space I have. And I also know down the road, I'm going to have other applications where I don't have, where I'm going to have to hang the gear off of something. So I have to have something that's going to work with that. In the back of my mind, I worry about all the scenarios, and I try to come up with the one that I'll adapt to almost all, or with very little grief and agony to the others. Not sure yet. Oh heck, I forgot I had the smoke wired up. I didn't see any smoke, did you? Oh, I didn't have the fan. Oh, jeez, dumb. Okay, so I don't know what time it is. I lost track, but we got a late start. Anyway, I got the two pieces working independently and my little lab board here, kind of fun. I had this built. I'd only used it once or twice. I'm going to try this again, see if it works. It does work. It's not perfect, but it does work. I can put parts down here. I can put the pieces up here. I could have mounted those onto a piece of balsa wood or something if I wanted, or I could have just stuck them to this thing, I suppose, and just had one in each or something like that. I don't know. There's a way to get around all that and make it work. I could also put the engine in here. I think the little things will fit down in there, and that would work. But anyway, this is how it is now. And of course, this is set up to put down the controllers. I fried the controller, ordered new parts. They're coming today. The Super Duty motor controller parts are coming today. And the Super Duty motor parts are designed for this guy. Now, I kind of put it aside, but I haven't dropped it. He's got a pair of arc magnets in there, and he pulls twice as much amps as anybody else. Well, guess what? My Super Duty stuff that I'm getting will handle that twice as much amps. So 3 times as much, actually. So I'm going to try him again, and just to see what we get out of it. I'm trying in my brain to figure out a way to devise some kind of a dynamometer. Cars, we call them dynamometers. You put your car on it, and your rubber wheels turn a roller, and the roller's spinning in either oil or something, and it has a resistance, and the more resistance, the more power, and you can measure that while you rev up your engine, blah, blah, blah. We're trying to think through how we could do that. It's going to be interesting because these tires don't have really good traction, and I'm not sure. It may be something that we have to bolt to a wheel and then bolt something to that wheel, direct. And they do that in the dynos too. They actually can take off the wheel and bolt it up. And that's pretty exciting. Anyway, so this is where I'm at. I am putting this together. Today is Saturday, bad day. We had to drive an hour in the rain and have a big lunch and then drive back an hour, so the day's over. But I wanted to get something set up so that tomorrow is what I do. I come up with a good trigger. Now, this switch seems to work. I've tested it by hand. It works great. It works better than that one. And that one has been, let's say, manhandled a little bit, you could say. So there's a possibility I can tune that up. I can slide it, rearrange it, slide it over, change the profile, and I might be able to get this one to work a little better than that one. And this one has been apart and together a few times. Okay. I may try to do that first. But still, I have this open and close thing. I don't know how I can make that work. I might do a diode on that input. I don't know. But at any rate, we'll see what I can do for that. Then can I do 2 switches? I don't think I have room for 2. Put one up high maybe, but it turns into a kludge is a kind word, right? Okay. Turns into a kludge. I mean, you could put one over on this side, be totally different. That bar would have to go across. This thing would have to get cut. And then you have to hold the 2. Oh, wait a minute. Okay. Then we get down to the infrared. And I have the one infrared piece I've made. It's around here, or it was. It's somewhere. I know it's somewhere. And I have those infrared boards. I have them somewhere. I had one out just the other day. They're around somewhere. tucked away. I can pull those out. Put a pair of infrared boards and just stick them, hang out, big kludgy looking thing. But if it works, that's the key. Hang them out, kludgy, stick them in, aim them at the stripe. One stripe for the puff, one stripe for the chuff. Stripes on the same stripe or on the same location, pulled over by the gear. I could put my plastic gear in with a stripe on it. That gear works real well. The one Andy designed, one like that. I could put that gear in and test it, right? We got 2 pulses, 2 different grounds to 2 different systems, puffing and chuffing, and then I have the heat into the puff. So you get the puff, fan, smoke comes out, and the chuff sound, and your ear and your brain should say, wow, it's puffing and chuffing, man. Okay. That if we can do that tomorrow night, I'm okay with that. Even if it's a glob, something that won't even fit in the engine. I don't care. I just want to see these components synchronized and working. I can always think about it and shrink stuff down. I think. Usually. Maybe. Or not. We'll see. Okay, well, I think that's about it. I don't know what time it is, but I'm just going to call it because I'm tired. So I suppose I ought to do something. So let's turn on the motor. And let's turn on the... Nope, that's not it. This is it. I told you. Got outside power I have to turn on. There's the chuff. Pulse is coming in through there. Now, notice, every once in a while he hits the cam and every once in a while he misses the cam. But if I stop the motor, all right, I stop the motor, but the power is still going to the chuff circuit, right? You see? The chuff guy can handle it. This guy is not doing his job. Don't do your job. Okay. Now, if I switch the sensor to the input to the fan, you'll see this fan will pulse according to those chuffs. So I did that today. Those items work. If I could somehow isolate that common, I don't know, maybe I could through a diode, I'm not sure. But if that would work, then I could use a single switch, and that'd probably be the easiest thing for me to do. If not, then I'm going to have to go to 2 infrared sensors until I get these magnet switches. And I think these are the really tiny little, they're smaller than this light. Smaller than this light. The chips, really small. And they come on 3 pins, and you just put them in there and you wire them up. And you would just glue them to the inside of a piece of plastic and just hold them next. Actually, they'd be out here next to the gear, and the gear would have the magnets glued onto them. So it would just go by, one on each side, I think, or maybe one here and one here, kind of a thing. So you do the 180 trick. So one could be here, one could be here, but the trigger's the same because you have 2 or 4 or whatever. And so I could do it that way and get that done. I'll order the switches. I'll pick 4 or 5 of them, see what the variables are. I'm looking at cycle time. Cycle time's in the micron seconds, millionth of a second. It's like 300 millionths of a second. How fast? I don't know. I'll have to guess. But anyway, that's the thing. I'll try to do that tomorrow so you know what this is going to look like and sound like. Okay, gotta go. We'll talk later, gang.